For a class project, a political science student at a large college wants to estimate the percent of students who are registered voters. She surveys 500 students and finds that 300 are registered voters. Compute a 95% confidence level for the true percent of students who are registered voters and interpret the confidence interval. Before we perform any computation or to answer any question, we should read the question carefully and summarize the given information in symbolic form. 500 in this case is the sample size, so n equals 500. 300 is the success, the number of registered voters, x equals 300. We're looking for the 95% confidence interval, and we know that the critical value z that corresponds to the 95% confidence interval is 1.96, which is approximately 2. And we are constructing the confidence interval for the proportion here because this is for the categorical variable. The confidence interval for the proportion is computed using p hat plus or minus the critical value z times the standard error for the proportion, which is p hat times 1 minus p hat over n. And so what is p hat? For the proportion, p hat is the number of success divided by the sample size. This is 300 divided by 500, which is 0.6. And so everywhere we see p hat, we would replace it with 0.6. The critical value z star is 1.96 and n is 500. And so this is 0.6 plus or minus 1.96 times the square root of p hat is 0.6. 1 minus p hat is 1 minus 0.6. Instead of writing 1 minus 0.6, we simply put 0.4 because 1 minus 0.6 is 0.4. We would rather write 0.4 instead of 1 minus 0.6 in this expression underneath the square root, and n is 500. There are two computations here. The lower bound is 0.6 minus 1.96 times the square root of 0.6 times 0.4 divided by 500, and we would plug everything in a calculator, and the calculator will give us 0.56 rounded to 2 decimal places. Another computation is 0.6 plus 1.96 times the square root of 0.6 times 0.4 divided by 500, and this is 0.64. So the confidence interval is 0.56, comma 0.64 with the set of parentheses. This is the 95% confidence interval. We say that we are 95% confident that the true proportion, or in this case, the percentage that they want, the true percentage of students who are registered voters is between 56% and 64%, because 0.56 is 56% and 0.64 is 64%. What this means is that if we were to construct 100 confidence intervals, 95 of those confidence interval will capture the true percentage of students who are registered voters.